So here we go. Delta x equals 1/2 at squared, and our values were negative 0.95 equals 1/2 times negative 9.8 times t squared. Okay, I'm going to save my math for the end. So to solve for t squared first, I want to multiply by 2, because the inverse of 1/2 is 2. So I multiply by 2 on each side of the equation. And then I want to divide by negative 9.8. Divide by negative 9.8. Okay? 1/2 times 2 is 1. Negative 9.8 divided by negative 9.8 is 1. And we're left with t squared on the right side. On the left side, we have this big expression. Okay? And I'm just going to rewrite it. I'm not going to solve it just yet. 2 times 0.95 divided by 9.8. Now notice I got rid of the negative signs because negative divided by negative always gives you a positive. So I just rewrote it without the negatives. And now I'm going to solve for t by taking the square root of t squared. That's an inverse operation. And I get t equals the square root of this number. So I'm going to grab my calculator, do it on the side here. And I've got 2. Give me a second. 2 times 0.95, that gives me 1.9, divided by 9.8 gives me 0.193. Take the square root of that, I get 0.440. 0.440 seconds. So that's my time, right? So that's the value, that's the amount of time it's in the air. I can come back up here to, I know this value now. I just solved for t. Whoops. I know it's 0.440. I'll just put 0.44. I can substitute it in anywhere I see t. 0.44, right? And now, if you look at this equation right here, right, this one's down to 0, so it's gone. It's just 1.5 times 0.44. So I just multiply by 1.5, and I get 0.66. 0.66. Now, we were using our standard units of meters, seconds, so I know it's 0.66 meters. That's how far it's going to travel horizontally. So I just solved for delta x. So right here, I can replace it with 0.66 meters, which is 66 centimeters. And then I would measure from the edge of the table, and that's the cup it's going to land in.